Hey there, I'm Nix, and today I'm going to be solving the find numbers with even number of digits problem, which has such a lovely title, on the LeetCode website. I'm going to be doing this in C++ and giving you a fairly detailed explanation all the way through the process, from the planning stages, the logic that goes into making the working algorithm, through the actual code, and then having a little bit of time complexity analysis sprinkled on top. If that sounds interesting to you, then stay tuned. Welcome back. Now, as is probably going to become tradition for me, I'm going to, before I do anything else, implore you to, if you have not already done so, go to LeetCode and try out solving this problem for yourself, because the practice that you get, the problem solving, going through that entire process, explaining to others, even if it's just you alone, all by yourself, explaining to your computer screen, that practice is so crucial and so precious for you being able to improve your coding or being able to get more comfortable in a technical interview environment. Whatever your reason for doing it, try it yourself and then come back and watch the video and we can compare notes. Okay? Sound good? Good. Now that we have that out of the way, first part of what goes into solving a problem for me is planning stage. There are always three parts: planning, the actual code, and the analysis of the code. Planning stage is where you read the problem, make sure you understand the problem, and start trying to figure out how to go about breaking it down to solve said problem. Don't actually do any coding yet. Now, given an array nums of integers, return how many of them contain an even number of digits. And LeetCode is very nice in giving examples to help clarify. So we have an array here, and the output is 2. 12 contains 2 digits. 2 is an even number, so it counts. But 345, 2, and 6, containing 3 digits and 1 digit, respectively, those are all odd, so they don't count. But 7,896 contains 4 digits. 4 is an even number, so it counts as well as 12, which means the total number is 2, hence the output. Okay. Next thing I want to pay attention to is the constraints. Constraints help to figure out if there are any specialized edge cases that you don't need to pay attention to for the purposes of the problem. With these two constraints, there are 2 edge cases that I don't have to worry about as a result. The first is, since they're giving me the length of nums being within this range, it indicates to me that I don't have to worry about being given an empty array that doesn't contain anything and covering for that, because it's always going to contain at least one thing, which is good to know. The next thing is, looking at this constraint, I'm only dealing with positive numbers of a certain size, and I don't have to worry about any of the numbers being 0, since it's always going to be greater than or equal to 1. That is also very useful to know. Biggest thing that jumps out of me is I'm going to need to figure out how to count the number of digits that a number has. So, thinking back way in the past to, I don't know, early elementary school? Is that when we learned about, the ones place, the tens place, the hundreds place, and so on and so forth? Somewhere around there. These digits are essentially magnitudes of 10, powers of 10 every time. You have the ones place here. You introduce a multiple of 10. Suddenly you have 2 digits, get a number in the dozens range, multiply by 10, again, then you have a number in the hundreds range, multiply a number in the hundred range by 10 again, you get a number in the thousands range, and so on and so forth. So if you reverse that and divide a number by 10 every single time, you can use the number of divisions of 10 to count how many digits it has. So that is going to be a useful thing to do to figure out how to count the number of digits. Now, to help illustrate that, I am going to have to do some editing and introduce a little helper of mine. So come on out, little helper. See? A nice whiteboard. No, wait, don't run away. It's okay, I get it. Whiteboards. Horrible, bad, unpleasant memories. I get it. But this is a nice whiteboard. This is a helpful whiteboard. It's good. It's mine. It's going to be very useful and nice and not scary in any way, shape, or form. All right. Now, whiteboard, help me illustrate the concept of doing these divisions and the advantage of using integer division and how that works to my advantage. So let's have a number, 947. Let's pop that on there. And let's also have a column that tracks the number of times that I divide by 10. Thank you. So we have 947. We divide by 10 once. Count that. And we, as expected, get 94.7. But the thing with integer division, when you have a variable that's labeled as an integer, it doesn't care about that decimal place. It treats it like a scalding hot stone and drops it. Pretends it never existed in the first place. So, drop it, whiteboard. Thank you. So instead, it becomes 94. You divide 94 by 10 again, and it becomes 9.4. Again, that decimal place is dropped like a hot stone. And as you can see, no rounding is taking place. It just literally pretends it never existed in the first place. Now 9.4 becomes 9, and you go through another round of division again. 9 divided by 10 is going to end up being 0.9. 0.9 is again chucked into the void, and we end up with 0. Looking at the number of times we've divided, we end up with 3, which is exactly the number of digits that are present in the number. And as you can see by going through this process, any number that we take here is eventually going to be reduced down to equaling 0 in terms of an integer, which is going to be a nice condition to key into. Now going through this, obviously I'm going to need a variable that keeps track of the number of divisions that I'm going to do. I also need another variable that's going to track the number of integers that are present in the array that end up being even, that having an even number of digits. Going through this iteration process also clues me in that I'm going to need some sort of nested loop. I'm going to need an initial loop that iterates through the array, and then I'm going to need another loop that is going to iterate through the number and divide it by 10 over and over and over again until it gets to 0. Then the count of the digits is going to be accurate, and I can stop. After that, I'm going to need to take that accurate count of the divisions and evaluate if that is going to mean it's an even number or not. And if it is, I'm going to count it. That is the general outline of the plan of attack I have, and the explanation of how integer division works and how it relates to this problem. So thank you, Whiteboard, for displaying all of that in a nice, easy way. Great job, and Not entirely sure whether I'm going to be keeping you on screen or eliminating you, so that's going to be a question for future me when I'm editing this video to decide on. Now, planning is done. Moving on to the next stage of the problem-solving process. The code. In this video, I'm going to try my hand at jump cuts, so I can spend time actually talking, trying to think of engaging, interesting things to say. Whether or not I succeed at that is debatable, but I'll try. And not worry so much about how slow my typing is. I'll just do jump cuts to instantly put it onto the screen. And we'll see how that works out. First up is the variables. I want to create those. And boom, there they are. So these are my two variables. The number of divides is, as its name suggests, going to keep track of the number of times I have to divide it by 10. And the number of evens is going to track how many integers in the array turn out to have an even number of digits and get counted as a result. Now that I have those variables, the next thing I'm going to put in is the for loop. Just like that. Typical for loop goes through the entire array into I starting at 0, I less than nums of size. Now within this for loop, I have to iterate through those numbers and do the divisions. Now, I don't exactly know specifically what integer is going to have how many digits. In other words, I might get an array with size 3 and the first number in it could be a single digit, or it could be one with 5 digits. It could be 6 versus 60,000. I don't know. Because I don't exactly know how many specific times it's going to need to run, a good loop to use in this case is going to be the while loop, like so. I know it's going to run for a couple of times depending on a specific known condition. I want this while loop to run until that integer that it's looking at is equal to 0. While that is not true, it's going to run. So, while nums at position I is not equal to 0, we're going to do stuff. That stuff being that we want to take that integer and divide it by 10. So this just sets it equal to itself divided by 10. This is a shorthand version of saying that. Set nums I equal to itself divided by 10. This is just an easier, less typey way of saying it. Then once we do that, increase the number of divides counter by 1. Do that over and over again until nums I equals 0. Once it equals 0, we break out of that loop. After we have an accurate count of number of divisions, then we need to evaluate whether that is even or odd. And that's going to be done by an if statement. It's going to be outside of this while loop, but still within this for loop. So right after these paired brackets right here. Okay, that if statement is right here, and this is the condition that is being used to determine whether that counter ends up even or odd. The way we do that is by use of this operator right here, the Modelo operator. This operator essentially says that, hey, this number right here, number of divides, I want you to divide that by this, and then look at the remainder of that integer division and take that remainder as the answer. That's the Modelo. So as an example here, if number of divides is equal to 4, 4 divided by 2 is equal to 2, remainder 0, because 2 evenly goes into 4 2 times, with nothing left over. if number of divides is equal to 5, 5 divided by 2, you get 2.5, so 2 remainder 1. That modello, it will evaluate out to 1 instead. So every time an even number crops up, it's going to have a remainder 0, and thus you're going to be assured that it is even, so we count it, we increase the number of evens counter. Now at this stage, the for loop has ended, and the last bit of code that's to be added is going to be the return, where we return that. So we'll just quickly insert that in, making sure to have it outside of the for loop, so outside of these brackets, like so. Now, before I do any sort of running code where it's kind of the equivalent of me saying, like, yeah, I think this is my answer, I think this is good, I don't see any problems, I just want to do a little bit of a mental run through of loop to make sure that the code evaluates and is doing what I want it to do correctly. Got the variables set up, both are set to 0. We start at the first place. So while the number, in this case 12, is not equal to 0, 12 is not equal to 0, we're going into the loop. 12 is equal to itself divided by 10, that's going to evaluate out to 1.2. Integer division, we're going to throw away the decimal point, we have it equal to 1 now. We count that division process, so number of divides is now equal to 1. 1 is not equal to 0, so that evaluates to true. And we go into it again, we divide 1 by 10, we get 0.1, throwing away the decimal again, and that's going to evaluate out to 0 the next time. We count that division process, so the number of divides is equal to 2. That is an accurate count of its digits, so it should stop here when it loops back around and tries to see if this condition is true. By now, num's I is equal to 0, so this condition evaluates to false, and we no longer go into this loop. So good. That looks like it's good. If statement now comes in, we look at this. Number of divides is equal to 2 in this case. 2 modello 2. 2 divided by 2 is equal to 1, remainder 0. That remainder is what I care about, so is 0 equal to 0? Yes, yes it is. We go into it and count number of evens, increasing that by 1. Now we've gone to the end of the for loop, and we're going to swing on back and move to the next one here. And this is where you see a little bit of an error that could crop up if you went and hit the run code here. This error is due to the fact that you have not reset the number of divides. It's still at 2, and if we still are running through it, 345 is not equal to 0, so it's going to go through a division, and it's going to bump up that number from the previous count of 2 from the number to 3, and it's going to mess up everything. So in this for loop, before it begins, we always have to reset the count of the number of divides to be an accurate counter for each individual integer. Now, I could input that, but it's just easier to do this. The integer definition and declaration of number of divides doesn't really have to be outside of the for loop. It doesn't need to exist outside of the scope of this loop, so there's no real point in being repetitive and writing number of divides is equal to 0 again within this loop when I can just move the definition and declaration line that I had out here in here. makes for a little bit cleaner look to it. Alright, that fixes a potential error that could have occurred once you started to run the code. And everything here, once we get out of the loop here at the end of the array, we're going to return number of evens. Number of evens is indeed the variable that holds my final answer. So now I don't see any issue with any potential error that crops up. Now that we're done with the second phase, the coding phase, we're going to move on to phase 3, the analysis and evaluation. So this involves me clicking buttons for a bit. Run code. I do not want to see any compiler errors cropping up, and indeed I have not. Excellent. And this is a good sign. Input here a different, actually this is the exact same one. My answer, expected answer, evaluates the same thing. That's great. So let's do the full submit where it runs through every test case. Judging. Accepted! Yeah! Success is always awesome. Alright, now before I hit this button, I'm going to do my own analysis of time complexity first, before I look at what LeetCode judges me as. Now here, usually when you have nested loops, a good kind of rule of thumb is that will usually mean that it ends up as a big O of n squared. However, that's not the case here. Now, big O of n squared means that n is usually stated as a variable that means the input size, in this case the array size. The bigger the array, the longer it's going to take to run. Big O of n means it runs in linear time. Big O of n squared, it runs according to a square of the size, which means it's going to take much, much longer. However, as I said before, this isn't the case with this specific algorithm. And the reason for that is because the two loops here, the for and the while, depend on different things. The for loop is running through the entire array size. It is dependent upon that array size. The bigger the array is, the more times it's going to run. If the array size is 2, this for loop runs a total of 2 times. If the array size is 1,000, the for loop is going to run 1,000 times. However, this while loop here, does it really depend on the size of the array? No, it doesn't. It depends on how many digits an integer has. If the digit is 7, this while loop, with 7 only having 1 digit, is only going to run once before it ends up having a false condition to it. 7 divided by 10.7 ends up as essentially 0, evaluates the next time to false. But in a different example, if we have 7,000, this while loop is going to run 4 times instead of just once because it has 4 digits. Now, 7 and 7,000 could be 2 integers in an array that only consists of 2, or they could just be 2 of 1,000, but it's not going to matter because their 7 is still going to run only once, and 7,000 is going to still run only 4 times. This does not depend on the array size and thus depends on a different variable. So in that case, because it is within, it is a nested loop, it's going to be big O of n times m, where n is a variable defined as the input array size, and m is a variable that equates to the number of digits in an integer. So this algorithm here is going to have time complexity of big O of n times m, not n squared. Okay, now that that is done, let's see what LeetCode judges me. Okay. Very tight runtime here. So these, at least in terms of LeetCode's judgment, is fairly equivalent in terms of real-life usefulness. Again, I take these specific values with a big grain of salt because I have indeed run some experiments and submitted the same code at different times, and I've gotten different places on the graphs here. So take with a grain of salt. However, what's useful is if you click on these columns here, you're going to get examples of the code that it falls into those brackets. So it's a really good way of seeing what others have done, and is a great learning tool. 66 point here, 9,600 to 10. Again, really tight spread of the space complexity as well. That was the find numbers with even number of digits. Again, great title for this problem. I hope that it was informative and hopefully a little bit entertaining as well. So if you're someone who is improving their coding skills, if you're practicing for technical interview prep, whatever it is you want to do, I hope that we can walk down the path together, and have a good day.